Strategies for factoring polynomials. We'll start by factoring out a greatest common factor. 25x cubed minus 15xy is a binomial. We can see that it has a greatest common factor of 5x. We're going to factor a 5x out of that binomial. We can do that by using this box strategy here. And we can think 5x times what is 25x cubed? 5x times what is negative 15xy. So now my two factors are along the side and the top of the box. I can represent the original binomial as 5x times 5x squared minus 3xy. Now let's take a trinomial where the leading coefficient is 1. X squared plus 12x plus 35. Recall that we could have arrived at this trinomial by using the FOIL strategy for multiplying binomials. Therefore, we'll kind of reverse engineer this and use the reverse FOIL strategy. F stands for first two. So what times what equals x squared, and we'll write that in the first slot of each binomial. L stands for the last two terms. The last two terms will multiply together to equal positive 35. And they will also add together to equal 12. So we'll come up with 5 and 7. Both of them have to be positive because the trinomial had all positive signs. Now we'll check using our FOIL acronym. The first two terms multiply together to equal x squared. The outside, 7x, and the inside, 5x, also add together to equal 12x, the linear term. And the last two terms, 5 times 7, equals 35, so this checks out. I can factor the original trinomial as the factored form we see in either order. So I can write it as x plus 7 times x plus 5. Now we'll factor a trinomial where the leading coefficient is not equal to 1. And we have talked about using the reverse box strategy for this, and we set up the box so that the top left term is our quadratic term, and the bottom right is our constant. We multiply those together and we get 12x squared, and we remember that the terms along the other diagonal that are missing will also multiply together to equal 12x squared. So we want to start listing factors of 12x squared. Then we want to notice that the middle term is negative. And so we want a group of factors which will also add together to equal negative 8x. The only way that'll happen is if both of these are negative. I'm noticing the middle set of factors are the ones that I want, so I want to write them along the diagonal. I'm going to choose to put negative 6x at the top, simply because it's compatible with 3x squared. I'm going to look at the top row of terms in my box, and I can see that 3x is a factor of both. And now I can just fill out the rest of my box because 3x times what is 3x squared? This is the way I'm going to think. Now along the top, I'll think 3x times what is negative 6x. Down the side, I will think x times what is negative 2x. I'll just make sure that the two numbers multiply together to equal the constant term. Negative 2 times negative 2 equals 4, and it works. So I'm going to represent my factored form as 3x minus 2 times x minus 2. Now let's factor a trinomial. But because there is a greatest common factor, we're going to factor that out first. I can see that all of the coefficients are even, and there's a y common to all three terms. So I'll factor out a 2y. And now I'll just think 2y times what is 2x squared y. And now I've factored the first trinomial by taking out the 2y. I have a trinomial inside the parentheses that can be factored using reverse FOIL. And the first two terms will be x. And then I'll think what times what equals positive 7 that also adds together to equal negative 8. That'll be negative 7 and negative 1. And so I have factored my original trinomial into 2y times x minus 7 times x minus 1. Finally, we learned how to factor special products, and we have a binomial here where each term is a perfect square. They are separated by a subtraction sign, so this classifies as the difference of two squares. And recall, after kind of practicing a lot of these, we know that it factors into a minus b times a plus b, where a is the square root of the first term and b is the square root of the second term. So we can apply this structure, and the binomial factors into 6x minus 7y times 6x plus 7y. There was another type of special product that we learned. It was called a perfect square trinomial. And the reason why this classifies this way is because the perfect square trinomial, there were two types that we looked at. We have a perfect square as the first term, a squared. We have a perfect square as the last term, b squared. And the middle term will be twice the square root of the first and the last term. So that actually, this expression that we have here qualifies as a perfect square trinomial, where the square root of the first term is 5x, the square root of the last term is 3y, and you'll notice that middle term is definitely twice 5x times 3y. So we can factor it this way, 5x minus 3y quantity squared. So those are our strategies that we reviewed for factoring polynomials.